Hello, 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 folks. Advent of Code Day 19 is less than a minute out. Thanks for coming on by. As usual, our Quokka setup is ready. Our template here is running. Quokka is outputting our little text here from our input file and our sample test case. Everything here is ready. We're at less than a minute out. Again, for those who don't know, Advent of Code 25 challenges released daily at midnight Eastern, varying levels of increasing difficulty. Solve it however you want, put number in box to complete it, and fight against the clock. But here we go. Boom, there we go. I think we saw some of this logic with the monkeys before. This is cool. Interesting. Ah, okay. It can be one-lined. Very interesting. Let's fix that for this. We'll write in one parser today. Add up the quality, you get 33. Whew. Okay. Okay, let's figure this out. Collecting obsidian, waterproof robots, clay robots, ore robots. Okay, great. So let's see. Many blueprints you can choose from, but once you're configured, you cannot change it. Figure out which one is the best. Okay, so one collects one ore, two ore. Okay, so it's a bit of a math problem-y. So let's start parsing this out. For for equals data split. New lines, map, line. Here we go. Let's see. We have name and requirements. Each robot, each ore costs 4. Okay, it's not exactly what we wanted, though. Let's see what it outputted. Yeah, lots of bad stuff. So instead, each ore costs 4, clay costs 2, obsidian costs 3 and 14. Oh, multiple dependency. Great, 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 great. Okay, so I think it's each and then whatever cost something, something else. Gotcha. What we want to do is split by line dot split each. I guess technically I can regex. Sorry, brain is slow on this one. Line to lowercase. Each one or dot slice rec equals here. We look at rec and we start to see. Right, this is what we want. What we want to do is map rec dot split by the dot 0 is pretty equal. Great. Okay, and then what we're going to do is map rec. This can be rec dot. It's the first sentence, right? Okay, I got it. It's split robot cost. There you go. Let's get some spacing on these. Okay, perfect. Now the other one. So after we have that. Now, okay, so let's drop this here. Robot rec equals. Then drop that here. Big fan of robot. There we go. Now we return robot x dot rex equals rex dot split, and I think it might be close. Or okay, now it's getting a little too nested. We throw a console log or a return on these. Nice. Okay, so count for 2 resource or for robot. Okay, yeah, this seems accurate, if not a bit nested. Now the fun part. Okay, let's figure this out. 24 minutes is our limit. Great, okay, so let's, for const minute of 24. This is where the optimization for part 2 will show up, but we'll figure that out. Okay, so using blueprint 1, largest number you can open is 9. So the required order is basically this, right? We need the geodes. Yeah, we need geode robots. So we need ore, clay, obsidian, and then geode. Geode needs obsidian. Obsidian needs these. Okay, and I have to do the asset distribution to make sure when we create an obsidian robot, every minute it goes by. Spin 2 to start building. Okay, I understand. Gotcha. Okay, so const robots equals empty 1 ore collecting robot connects 1 ore. You have a 1 ore, right? Or I guess we're just gonna give you a type of ore. Const inventory equals ore. Zero. What are the other two? Clay 0, obsidian 0, geode 0. Robots, which could really need to be array, it can simply be inventory. Got the robots dot ore is 1. And so it begins for main count of robots for objects and entries of the robots. There we go. Not making count robots. Is count inventory plus equal that many. And there we go. We want to make the geode robots. So, those, in my mind, in this order, but it might be a better order for the actual production of them if we have enough space, right? So find the what we want to make. Effectively, we already found the blueprint, right? So, possibly blueprint, right? How it works? Blueprint one, yeah, so let's do it. So already have our blueprint based on that. Right, robot is what we want to make. Well, let's give us find our robot. I'm going to do that check. There we go. And then decrement. That's not how this works. Start printing out items like that. Let's give it a say goodbye there. And yeah, okay, so we're making geode, and I need all these things. Yeah, let's flip this object around into a mapping. Like an argument. Initialize our reduce, and then object resource code. So now we can see a geode needs 2 ores of obsidian. Over top. There we go. Okay, let's make a new resources equal object. I mean, we want to copy the old one, right? So, for inventory. New inventory. Okay, so going over, we know the best kind of TypeScript. Oh, I'm sorry, did it do that? That's it did get lower for some reason. Thanks for pointing that out. You do, but we need to get rid of it. Also, real check your output looks good. Wow, yeah, weird. Yeah. If you see, yeah, weird microphone. Why you be doing this? So, trying to unplug it, but hopefully it doesn't. BC. There we go. Okay. Don't know why it decided to went out. But thanks for telling me about that, Goop Goop. Oh, I hope your night has been going well. Resource is above or equal to count. There you go. Decrement. And we're going to say let failed equals false. Failed equals true. And ignore that one. And the next one. This robot technically is good enough for this, but that's okay. What we're going to do is once we have done this, we're going to say if not failed, then we're going to do a cool assignment. Perfect. And then we're going to increase the robot. Well, hold up. Another confused TypeScript. Got it. Like so. Drop this return, and it should be doing the magic. And what are we trying to do at the end? Multiply blueprint ID with largest number of geodes that can be opened in 24. Well, hold on. The first blueprint had ID and can open 9 geodes. Okay, so I'm counting how many geodes I have plus my ID. So I guess we're going to say, like, let best equals infinity or negative infinity into our lovely loop. I guess my inventory and stuff needs to be defined inside the loops. That makes sense. That's not right. Boop. There we go. Okay, now in here, we gotta do our calculation. Yeah, but it's blueprint ID multiplied by this, which is literally the index. Or is there something else? Okay, it's index plus 1. We can manage that. Or we can just shove it in here. Okay, here we go. Well, blueprint is an array of things, right? So console log blueprints 0. Yeah, it's just an array. Wait, what is it? It's an array and an array. Well, that's kind of sad. Okay, we're using indexes then. I ain't gonna muck that up at all. There, great. Now we have our b to multiply by. So it is multiplied by the index. There you go. There's some quick math for us. Then we return the best. 58 is not equal to 33. Second has a 2, can open 12 geodes. Okay, yeah, we can literally console log this. So console log b plus 1 and your current inventory. Okay, so you got no geodes. You got 29 geodes. I thought Blueprint 1 actually made something. It looks like we got a broken loop there. 9 geodes. Hold up. First one is an ID of 1, can open 9. Second ID of 2 can open 12. Well, that's not working. Geode, obsidian, clay, ore. Okay, so all this is happening. So let's see what robots you got too. Since we're checking up on y'all. Okay, we have 1 ore, 12 clay, and you have 6 geode. Well, if you have 6, okay, that's why that makes sense. Okay, I guess we can start console logging in this way here. Okay, so let's console log. Hold on though. For every count of robots, add 1 ore. Yeah, that's right. Ore collecting collects ore you now have. I keep putting all the words in here. Awesome, great, lots of things to fill in here. So we're going for name, well, count, then name collecting roulette collects. Name you now have. Inventory name. Again, that feels wrong, but oh, keep on. Come on. We'll just see if this looks right. Yeah, so one ore collecting creates one. You now have one ore collecting creates. Right, and then 3 collects 3, 6. Yeah, that looks like good math to me. Let's add our additional logic as the header. Minute. M looks good enough. Well, it's M plus 1. Sure, we can handle that. Plus 1, I said. I think we make it all the way end. Come on, logs. There you go. 1 to 24 as expected. And then for my robot construction, if I haven't failed, console log spend to start building. Where is it? And something collecting robot. So this might need to be done before the collection. I'm starting to see now. Yes, spin to collect. It is ready. You have 2 of them. Yeah, so we spend it, then we collect it. There might be multiple spends happening during a single point. Can we only make 1 a robot? Or 1 per cycle? I don't see that logic anywhere. Okay, let's just see if this works. Spend string equals, there we go. To start making a want to make collecting robot. Now why is this on fire? Okay, great. So this is running. Let's give it a real run so I can actually visualize this output. And explosion. Okay, so let's see what we got here. We got robot 1. 1 spin 2 ore to start building a clay. 1 ore collecting robot collects 1. I have 1. I have 2. So minute 3, I have 1 ore. Minute 4, I have 2 ore and 2 clay. I spend a lot of 2 ores to build a clay collecting robot. Yeah, this is the dependency chain. It keeps on going, even when it should not. So what I need to do is be saving or waiting until I have enough resources to build what I want. Plus, I need to actually be building this in the correct position. So let's say up here, we're going to say const new robots equals congratulations, and then this logic happens here. We update new robots, not real robots. Then we do the assignment. Then what we can do here is, I guess we can do a log, but we can just do some stuff here, I suppose. Don't really need to. It's good enough. Boop. Should make it a little more readable. Progress, progress, progress. There we go. Spend 2 ore. You have 2 ore, 1 clay. Good. Then 2 and 4. Now 1, 6, 3. Hold up. Spend 2 ore to build a clay collecting robot. 1 and 6. Good. Okay, yep. Now I have 2 and 9, 3 and 12. Then 2 ore to build a clay collecting robot. Spend 3 ore and 14 clay to build an obsidian one. Keep spending 2 ore to build these boring robots. So I guess once I have resources coming in for that robot, I should not be building the old one. Let's see what buildings I do. Start building a something robot. See what this looks like. So I build clays, then geodes. So I go straight from clay to the geode ones. No, right here I build another one. Start building. Okay, and great. We have grammar in the vested now. Okay, so it's clay, 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 obsidian, clay, obsidian, geode. Great. So we have this resource management thing. I guess I could technically go dynamic programming and be like, oh great, the universe in which I did or didn't buy it at this point. But there should be an easier way to be like, which one am I supposed to buy? Right now, just keep on buying clay ones because I can. So my resources can go. Interesting. So I guess what I can do is check, hey, if we are getting close to our ratio of needed materials, wait a minute. Like, wait and don't go for any other robots. But as in the example shows, I do build other robots while waiting for geo resources. Yeah, so like right here, I build all the clay ones. We keep building clay ones until we have enough for an obsidian one, which is 3 ore and 14 clay. But here, like I don't spend the ores to build it, to build the ore ones, to build the clay ones. I wait till I have enough for an obsidian one. But then I do build another clay one. It's all about knowing I have 29 minutes or something. Interesting. If this were dynamic programming, it'd basically be inventory, robots, and choice. Which I can put all in a recursive function. To build or not to build. Then that's multiplied by 4 for each robot that you could possibly be building or not building. This part one's getting me good. I guess we can start on that. Let's see what we got. We have inventory, record, string, number. Robots, same thing. And then we have minutes left, number. And then what more do we have? Because we have our blueprint ID, but that's accessible enough. Oh, we have our blueprint. Yeah, okay. This is okay. Nice, nice. Okay, yeah, this is actually a good one, Copilot. Good job. Minutes left is 0, then inventory geo times blueprint, or BID, something like that. Blueprint ID, but we do need to access the blueprint for stuff, so, yeah, the blueprint is this thing, but not faulty arrays. Congratulations. BID number. There we go. Oh, yes, we only need the blueprint ID. We didn't need the whole objecto. But great. Okay, so what we're going to do is our bit here, our bit there, and our bit there. So if we just clean... Oops, too many closers. Clean this up. Guess we do want this one. Now we're going to make our recur calls const cause best for B equals recur. There we go. New inventory, new robots. 24 minutes. Yeah, how many minutes is this? 24 minutes. Yep. And then our best logic. There we go. And you're going to return a number. So return 0, I guess. Okay, this sounds good. Let's update our ore robot because you get one of those. Where was that logic? Right there. Okay, good. Here comes the fun part. So if you can make the robot, you're going to split into a universe in which you did and a universe in which you did not. And this is always doing its thing, I guess. And finally, we return. This doesn't really. I mean, I think this does need to be recur, but. A lot of passing things around. Why are you angry? Recur has an any. Get over it. Cool. Be cool. Great, here comes the universe splitting. So first one, I suppose the easy ones, where we make copies of these objects to just be safe, because they're always mutating. And then the actual splitting of the universe. So we're going to have one where we do and one where we don't. So, I guess it would be a return right here. Return math max recur, and well, they're both, no, that's not right. And recur one where I do it and one where I don't. So this is where inventory, new inventory. So this is where I did it. Then it's want to make equals robots want to make +1. So this is where I do it. This is where I do not do it. And the minutes left goes down. We don't increase the blueprint ID. Okay, one of them technically is just continuing where I am. And then this kind of messes up the order because it's going to go back to robot creation, which actually does make sense. Okay, this seems all right. We hit an infinite loop. Nope, what's this? Get out of there. Now, we're probably doing is hitting an infinite loop somewhere. So I wonder if any of this is cacheable. I mean, we know it is cacheable. Inventory, robots, minutes left, bid. Let's spin that up. We're going to see a lot of logs. Yep, lots of logs. And then new inventory has a new inventory. Whoops daisy, I goofed on that one. That should help. Great, okay, and now it's running really fast. Lots of runs. Now this can most definitely, let the clock give it a shot. 0 does not equal 33. Okay, excuse you. Okay, let's hit this up with a stop and a cache. Because what are we trying? Oh, technically it did run. So let's drop that console log. All the console logs. I guess if we're going this recursion, then we are fine. Like, I'm trying to be a little more efficient here. We're fine not doing this. Because our direct inventory modifications are like this. Let's stay safe. Stay safe, folks. There we go. Now let's get into this. 24 minutes shouldn't be that hard to track down. It's basically our first decision split. Which I suppose will be one of these. Yep, so minute. Yeah, lots of minutes where we're just living on life. I guess we can make a new variable. 24 minus minutes left. That's not how math works. There we go, and let's fix math on that so that looks better. Plus 1. There you go, so we're on minute 1. We have 1 ore, right? Yep, we have 1 ore. On minute 2, we have 2 ores. Yay! And then on minute 3, we make the decision. Do we make a new robo to build a clay collecting robot? Want to make clay, or do we not? So we're gonna pretend we did. Now we have a clay collecting robot and 1-to-1. So that recursive call messed up my math. So after that, you were supposed to make a new one. Okay, so inventory increases the same, but we do it for multiple inventories, and then we return the best of the two, possibly n universes we just spun up. Okay, so let's see. Const options equals all the universes we could go through. So there's, technically this is inventories and robots. So, how would I loop that? So I think that's the only thing that changes, right? So we have the do nothing one, which is inventory, robots, and then here we got the one that we do stuff on. So options.push, congratulations, your new inventory and your new robots. Right, now this will work for the first one, but what if there are 2 robots I wanted to do this to? Then I'm doing this to new inventory. I need to do this to every possible inventory. Interesting. Say goodbye to these. Again, we're kind of unwrapping our recursion here already. Just ignore that lovely error. There we go. There's going to be looping over all our options for const inventory robots of options, not a slice. We just want to iterate through all of them. Doing that should put us closer to the goal. Inventory robots, correct. Okay, I'm loving that. It'll be for const inventory of options. Gonna modify all these inventories, and here comes the fun part. Return options or math.max options dot map inventory robots. Then we make our function calls. I'll fix that. Oh, it's gonna be a spread. Okay, that should be a little closer. I doubt it's gonna work, but let's give it a quick run. Zoom. Still console log lying around here somewhere. There we go. Yeah, we wanna be able to read this. Noticing lots of zeros. That's our minutes left. Oh, that's the end. We've reached the end for all those. That's cool. Okay, while this goes for a run, let's jump in here. Because this will jump in at the beginning of the recursion. That is where all life begins. There we go. Moment we start. There we go. We're gonna jump on through. We're gonna not build one, so we're gonna continue with life. I guess we jump straight to this one, right? Ah, boop, 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 boop. I messed it up. Gotta go to my robots. There we go. Still won't happen to completed. Nah, no completion yet. Okay, yep, so we jump in there. We have one options. It's the one original one we came in with. We get one or one of those. So jump on in. 23 minutes left. You have one ore, one thingy. Jump on through. You're still just making more ore. Great, love you. Then you have enough ore for a robot. So here's the split. You have two options. Lovely. One in which you made it, one in which you didn't make it, so you kept the ore. One in which you did not make it. You have now a clay bot. Now you made the clay bot, and the clay bot collected clay. The clay bot did not actually get a chance to collect clay on minute 3. On minute 4, the clay bot collects clay. So, do we just swap these around? Yeah, yep, exactly, Whoa, dude. The reducer is how I'm using to count. Wait, where exactly am I doing that? Yeah, for this one, it's just keeping an object where the keys are a name, the value are a number. Nah, it's not a derailment at all. Not really making much sensible progress, but yeah, the reducer pattern, classic way to either do a lot of things. In this case, it's to wrap up an array of key value pairs into a simple object, which looks like this. So it builds this little requirements object here. So instead of being an array where the string is or the value is 4, it's an object where the key is or and the value is 4. Probably whoa, dude. There is most definitely a TypeScript way of doing that. Though I do have a generic to get autocomplete on the object keys. I won't think that'd be possible. Well, I mean, I'm sure it is possible. I just I need to tell TypeScript which keys are available, and they'll all be optional failing, because it'd be a runtime that would tell you if the key was in existence. But a record of the possibles would most definitely work. Requirements. Yeah, okay, there we go. As record string number, but drop the string and it's, what is it? Where is it? How is it? Yeah, it's just the 4 types. So it's or clay, no, or, I don't know how to spell the word obsidian. Obsidian. Yeah, some of those TypeScripts can be magical for sure. Yeah, come here, get down there. Okay, yeah, TypeScript's having a field, well, VS Code's having the field day at the moment. But there you go, yeah, so you can have a record where we know the keys, well, we know what possible keys they are, what numbers they are. Of course, this isn't far from generic, but you can easily make these keys are generic right there. So yeah, far from fancy, but it's technically a little possible. Okay, so for my robot building and for these need to happen. I guess we need robots, but we also need new robots, right? Robots, new robots, or robot changes. There we go. Bingo bango. Yeah, so we're still pushing good old robots. But now we need a new object that contains our robot changes. Right there. There we go. So we still only touch our robot, and then this is robot changes. There we go. This should do what we want. Another try. Did we know? Nope, TypeScript still running eternity. Big fan, big fan. Of course, yeah, it's a very relatively common pattern, objectifying, because basically, like, instead of having to look through the array every time you want something, you essentially index, and this is like a database term, you index that, quote, column of data, so all your lookups become O of 1, basically, and this is just the programmatic way of doing it, the same thing that databases do when you use a ID column or something like that, that you index it you index by it. Okay, so let's jump where we jumped into. There we go. Our lovely options. 12012. Great, love to see it. Eventually we're gonna make a robot. Make a robot. There we go. Two options. One in which we do make the robot, or we don't make the robot. We have three or versus, well, what did we start off with? Ah, you mutated the original. That's not what we wanted to do. We want to use up all RAM that's possible. How dare you save RAM? We don't want none of that around here. Okay, I think we got 3 minutes to go through, so let's zoom, zoom, zoom. There we go. So we start with 2, we either add just 1 to it, or we spend some moolah and make a clay robot, which means we don't actually have clay until the robot is made. Beautiful. That's right, whoa, dude. You don't use it, you will lose it. Okay, so I think this is working now. Now our options, I'm afraid, is going to scale like all heck. But this is working. Oh, here comes the scaling I talked about. Oh, how badly is this going to scale? Yeah, it's going to scale a bit. I'm always I mean, I guess I have to go through all of them, but I'm always focusing on the most conservative of the outputs. But do I see any repetition, though? Okay, I guess I'll need to generate that. So, const scene equals new map record of string. Although technically, I bet I can 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I could totally do this. Ooh, we're gonna do something fancy I saw in a couple solutions I never got around to. We're gonna number. We can use some bit shifting. So const key equals. No, we're not doing that. Inventory dot. How dare you? How absolutely dare you? Inventory dot. Which one do we care about? What's the order? Or clay, obsidian, geode, right? So, well, that was a really great thought. Brain can't keep up though. So we're using strings. Const key equals JSON stringify inventory and okay, I guess it's one big object or it's an array of objects. Weirdo. Inventory robots. Minutes left and bid. If scene has key, return. Sorry. This isn't caching. We need to also update the value, don't we? Yeah, we'll figure that out. If scene has this, otherwise, update best. Cost best equals here. Add to the thing, return it. Yay, no more unneeded calculations. Let's drop this string while we're here. Hopefully, this root thing will work. We can try by just putting a little debuggy right there. See if this ever gets hit. Should probably hit the root at least once. There we go. Possible What do we got in here? We have nothing in here. Love to see it. Ah, now we're hitting some stuff. So this key got hit apparently. So what is that value? Okay, great. I mean, it's caching. It's doing the magic. Let's give this another rerun. Still hitting the cache. 49,000 entries. This is totally what we wanted. Yikes. So what key am I currently under? Yeah, get up there. 22. Yes, I have these numbers of these robots. Uh-huh. Uh-huh. This isn't what I really wanted. Okay, so again, my brain still hasn't thought of the actual solution yet, but this is literally try everything, and yeah, trying everything. Obviously not the way to go. We want, is this some kind of pathfinding in which I use, no, I don't think it's close enough for me to think of an implementation though. Okay, let's try to make it better. Key cost numeric key equals, see if Copilot. There we somewhat go. Heck no, that's not what I wanted. So what I want to do is inventory dot or plus inventory. Okay, so this is an idea, but what we wanted to do. Hey Zenitsu, how's it going? Oh, I can't. So my thought was to bit shift them all into a single number. Bind numeric values into single number via bit shifting. Let keynum. See if this works. Hey, I'm glad to hear it. Oh, negative 51, huh? What does that entail? Oh yeah, I mean this is advent of code, so that timer doesn't really always me equal break during these advent of code ones. Hmm. Okay, I don't know how to do that way. But yeah, usually if we try to at least get part one done before the break in question. Okay, I guess I could use the values to make this a little easier. Make it just an array of numbers. We love numbers. It's going. I haven't exactly figured out what I need to do. I'm just trying to brute force solutions to it because essentially we need to make a bunch of robots that collect materials, and then we need to use the materials to build other robots with our goal collecting the final material. But then for some of them, we need to be saving resources to make them. Then sometimes we need to spend resources to make other robots. So now I'm trying to see how to either smartly only like know when to save and when to spend, or right now what I'm doing, just brute force. When the brute force ain't doing the trick at the moment, but we are getting there. Right now, we're trying to brute force and just cache the results, which, I mean, the caching's working. It's just going into very big numbers, so probably not the proper strategy. Yeah, we have this cache of basically we're memo caching something, all the numbers. And it's working. It's just taking an eternity. Yeah, be like 25,000 that quickly. Yeah. Not exactly the most helpful. This is literally trying everything, and we need to not try everything. We need to try. Yeah, so this is why I think like we might need some kind of pathfinding or heuristic to keep us focused on a certain direction, making these last robots. Let's turn off the big one, actually. Do we actually even make it? So there are only 2 robots here. Well, it's 24 minutes. So I guess we need to keep track of which minute we make it to. We make it to a lot of minutes here, actually. Do I start throwing away old ones that don't have a high enough resource count? That would also be throwing away ones then which we're creating robots which are also of value. Yes, maybe here is where I begin the optimization of this recursive try all the things approach. There we go, so we have the same options, say goodbye. And here's, nope. And here's the first one. So, in this lovely universe, which one should we choose? The one where I make a new clay robot or the one where I don't? How would I even determine which one is going to give me more profit toward my goals? So I guess, yeah, so it's the resource dependency chain. So for this blueprint, I know the geode robot needs ore and obsidian, and the obsidian robot needs ore and clay. So I know I need to be collecting clay, so I will include it. I guess. But then it comes to the position of when should I not make a robot? Yeah, so like we have clay, 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 and then we save for an obsidian. Let's have 2, 3, and 4. Ah, okay, so I kind of see this. This is a future prediction. We think, okay, great. If I wait X minutes, I'll be able to build an obsidian one versus just building one anyway. So that's the heuristic I kind of got to go for. Yeah, so it will be const rounds to robot versus with current rates versus rounds to robot with new rates. Okay, which means the recursion approach might be getting waned away. But we'll give this one a shot. So this is basically every decision. We're gonna make this heuristic calculation. Okay, lovely. So let's stop this. You're not going nowhere. I'll give you a run. Let you do something busy. So my goal is to make the geodes, and this will be with and without this particular single generation. So let's figure this out. So calculate minutes until we can make a robot. So let's get back in there. Minutes until makeable equals, let's figure this out. That's not what we wanted. Okay, that's trying. Okay, so if resource is what we wanted to make, well, we want to make a robot. That's never gonna happen. There we go. So for each of these, we will seal requirements versus, we'll have to get our current rate of generation. So rates of generation for all of the inventory robots. Come on. There we go. Object resource count. No, stop doing that. Okay, that comment's now confusing it. Yeah, come on. Nope, don't do that. No, I mean, we are doing a needed thing. How many times are we looking at this blueprint? Mm, okay, we can also definitely optimize. I mean, that's um okay, yeah, lots of optimizations. Figure that out. Moment rates of generation. So for every resource we are generating, technically we already have that available on the thing by its actual number. So this was a waste. It's this close to what we want, though. Minutes until makeable. Okay, this might be useful information. Let's jump on in there and see what that looks like. Take a quick little peek. Nan. We love a good Nan. So I guess these all aren't returning numbers. Let's jump in there. In a moment. There we go. Needed to 1 divide 2. That's math last I checked. Yeah, 0.5. Ah, undefined. That's our problem. Did this fail? Nope. Requirements for the resource in question. Ah, so yeah, we are literally not needing that resource. So if we or it to 0, it'll be 0, or count divided 0, and count is 0, so 0 divides 0, which is nan, or 0. Well, technically minutes until makeable, largest number, right. So, okay, we can drop all these zeros in the pound, and give that another shot. Is command still running? Yeah, you're not getting anywhere. Drop that one. Minutes until makeable. So in 1 minute, I'll be able to make this. Versus if I do something else, how many minutes will it be until it's makeable? Now, I want to care about these 3. Technically, I care about geode, and then geode cares about the ones it cares about. So if the generation of this robot increases or decreases the minutes until makeability for the other robots, it's cool. So this is where I gotta figure out where to put you. Firstly, we can only do this if you're actually creatable. Great. So let's do this logic. Minutes till, come on, get up there. And then we're going through robots. So this is if you actually create it. And here is if you don't create it. If idle, if making. And we care about the next robot up always, right? Because, yeah, each depends on the last, technically. Yeah, so for Obsidian, we care about minutes until makeable for the geode. The clay, we care about minutes until making for this, for ore. Yeah, that feels right. So I guess we want previous rock. Cost, I guess we want index. Cost or there we go. Machines. There you go. This is gonna be on previous machine. Previous machine equals there we go, or the geode. Love that. Now you will focus on the previous machine. Perfect. Now here comes the logic. If minutes until makeable if idle greater than actually making it, I think I swapped these around. If making it is better than being idle, then try to make it. Or although we don't want to try, we want to actually make it. But we'll see about this, I suppose. That's a bit early. Okay, let's jump back into there. Minutes until makeable if idle. I guess we're doing greater than or equal to, since they can be equal and all that fun stuff. Hmm. Okay, so we're here. Where are we? Where are we? Where's my numbers? Show me my numbers. There they are. So you're gonna try make one. You're gonna keep on. This has been Useless Math with Rascal 2. Glad to see that all did something. Okay, so let's start tearing these parts out. I think this whole recursion solution was never gonna help. Maybe it just needs to be a simple heuristic, not some dynamic thinking one. Yeah, goodbye, 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 goodbye. Oh my goodness, these machines are in the wrong order. How'd this happen? That's awkward. Okay, so let's figure this out. Maybe we can make some hard-coded assumptions. Let's look at the input. Each obsidian robot cost. So look at the cost we have. Geode robots, all cost, or an obsidian. The obsidian all cost, or in clay. Okay, so all the costs are sequentially like hard-coded that way. I mean, the geodes and obsidians, you make them whenever possible. I think we figured that part out. It's the ore and clay that need to save because the other two depend on it, right? Yeah, so you always make the obsidians because they are our limiting factor for geodes. You always make geodes because you're making geodes. This is our literal goal. We have to figure out. Hmm. Da, 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 da. Where is the rule here? Clay collecting robot. Why do you make a clay collecting robot here? You have 4 clay. But I have 15 clay and I saved for the geode, or I saved for the obsidian. How did I know to do that? I saved for a reason. There was a reason for the season. Now, why did I do that? I just realized this math just got simplified, but my brain's like, let's think of other thoughts. Don't think of other thoughts, brain. Come on. Yeah, I think. Mm, We always want to make, so if geode or obsidian, then always make it, right? Okay, so if failed, you always make it means you don't do the other stuff. So yeah, so if you're always doing it, you're getting rid of the other stuff. Yeah. Um, this is last, not first. Maybe we can hard code this because it always does seem to be in fours, right? Yeah, I think I can hard code this. Let's drop the entirety of this. Okay, I have too many of these now. Where's my other one? There you go. Drop the entirety of that. So we always want to make, since it's all hard code, it doesn't matter anyway. So if inventory dot, so for the geodes, let's literally look at my input, bring it in here. Inventory dot or greater than or equal to, no, greater than or equal to blueprint. Blueprint equals blueprint. What is blueprint? Blueprint is an array of robots. Again, that could have been reduced. Geode robot. I hope you exclamation point. Thank you. Const geode robot dot requirements, or there you go. Yeah, so we do that manually, and we're like, if you can make one, then do it. I appreciate that, Hazenitsu. We are gonna do a lot of shortening once we get this working, for sure. Turn recur dot inventory or minus that, this minus that. Yeah, so we decrease or we decrease. Dang it, no, you didn't. You don't do all that. Geode costs ore and obsidian. You only decrease those two. There you go. And then you increase robots by 1. There we go. Now you do the exact same thing for cost obsidian robot. Or hard code in this one, folks. Yes, if you can make one, then always make one. Now these last two. Wait. Yeah, we can make ore collecting and clay collectors. Okay, now what's the math? What about these clay robots? Huh. Sorry, trying to think thoughts. Yeah, wait, what do I need for those? These both depend on ore. Got it. Uh, I guess this is where the options come in, because I can or I can't. Like, I'm always going to make these. This is guaranteed. These are the options. Okay, great. So, if inventory dot ore, because we always need at least, well, it's not 4 always. 2, 4. Oh, wow, okay. So for the ore robot, it literally is 4. And for this one, would you look at that? It's 4. Quick math. The obsidian. Okay, yeah, you're the one who's gotten all weird with the clay. So if this one is less than 4, I guess we're going to push to options. What are we pushing to options? Doing nothing? Oh, we already have doing nothing right here. But we're not pushing anything to options. Yeah, it's the other one. We want to say, if I can. Okay, we need costs. What's the robot? What's the other robot? The other robot. Clay robot. If you can make a clay robot, then push making a clay robot. Then, whoops. Apologies. Those of you astute ear, I am a little sniffly. Try to cover it, but a few of that may have came through. Here we go. Oh, hey, thanks for the follow there, Intervision. Hope your Monday's been treating you well. Yeah, so we make an ore robot, make a clay robot, then we return the best around. I guess it's the best of the recursion call. Wait a minute, what about increasing? Yeah, wait a minute, we never actually increment our things. I mean, I do down here, but down here's not part of up here. I guess I'm doing this. Okay, let's peekadoo. Again, making some hard-coded sets based on the data, not being smart. Great, okay, it fell apart. So if you have enough ore and enough clay for the geode robot and enough geode robot, don't take all these things. You take ore and obsidian. You don't take clay. Again, that's why you can't blindly follow your co-pilot, folks. So ore, obsidian, and then add one geode. Now for the other one, it's ore and clay, which you will update your ore and update your clay and add your obsidian bot. Good. Then options. Options of do nothing, just increase the number of ore. Where's increasing number of other things though? Where I'm not increasing the number of all my other things. Hmm. I guess it's technically I can do that. They're objects, but they're passed in and new objects, right? Yeah, they're always new objects. So I can modify them, but I'm modifying them after, not before. What if I just did this before, not after? Options. Oh, that's awkward. I'm not changing my code. I'm making an array of array. Be happy. There we go. Good enough. It's any. Well, don't be weird like that. Don't be weird, TypeScript. Be cool. Nice. I think on the last one, we'll want to stop. Or, because we're now doing it in a different order. I mean, if it's wrong, it'll be off by one. So we'll just look at that. Cannot access before initial is. It's literally right here. Oh, great. We have lovely stuff going on. Yes, we'll have to get rid of that. Probably was easier to do in the first place. Ooh, and off by one. There it is. So it's too many. I knew it. My gut was like, I'm gonna need to change this. 32, 33. Now it's literally off by one. Oh no. Okay, I guess I can, I mean, let's first drop the cache. Make sure I'm not over caching something. What was it supposed to return? You add up all the blueprints in the list. Wait a minute. Add up quality levels of all the blueprints in the list. You get 33. The heck was I supposed to do that? Okay, so that caching was doing good job. We'll put you back. Might, oh, I just hit the back button. Whoops. Okay, TypeScript, you're cool. Stop it. Okay, if you add up the quality levels of all blueprints in the list, 9 and 24, you get 33. Didn't realize I was supposed to do that. Sum equals 0, I guess. Sum plus equal I guess all I care about is the thing, so it's best for B times B plus 1. I'll do the math out here to make the math in there easier. Where is the math in there? I collapsed it, and now it's gone. Gone into the void. Yeah, you just return the number of geodes. Don't even think too many thoughts. Cute little function. Okay, now I guess we're just gonna stop here to do my manual inspection. See how many they can get. And I think if TypeScript can handle it, Quokka can handle it in a reasonable time. Great, so 24 and 16. First blueprint is an ID of 1 it can open 9. No. No, you cannot. So you make it to 9 geodes, but this thing says you make it to 24 geodes. So you cheating. Yeah, cheating little cheater. Okay, so I guess for this one, we're just gonna, where is it? Yeah, we're just gonna return quick and dirty. Best for B, because you don't need to run the other case. You fail quickly. Okay, I hope this never happens. If I have enough clay for an ore robot, do I never make ore robots according to this? Clay robot, ore robot. Start building. Clay. Oh, I guess I literally never make an ore robot. I mean, I kind of need ore, right? Can I not create ores? Each ore robot costs 2 ore. Oh, I go for the clay one first, don't I? Yeah, that's awkward. I want the ore robot to go first. We cool with this? We good with math? I mean, math was already cheating, so that's not really helpful for us. Let's turn off Quokka and debug into why we be doing what we're doing. Guess we're starting here. Come on, you. Okay, yep. So what do we have? We have an inventory of 1 ore. Love to see it. Can't make the geode bot. Okay, let's jump into all 4 of these. Interesting. We can make an ore bot though. So inventory ore is less than 4. Then literally just add ore to the inventory. Right, that works. Oh, wait a minute. Why? Whoa, hold up. Wait a minute. You're already adding ore to the thing up here. You don't double dip. Who do you think you are? You're double dipping. Oh, is it returning that number? Good. 14. Okay, still doing a bit more than it should. We have 14 geodes. We really only ever make 9. Yeah, at some point. Yes, we have 1 ore robot, all this other stuff. If we are stopped, then we return the number of geodes. We're doing cool caching, big fan. If we have enough ore to make, yeah, we do our increments. Gotta love that. We have enough stuff to make it to make geode. We make geode always. Correct. If we have enough to make obsidian robot, we always make it. Good. Otherwise, Otherwise. My brain was like, thoughts? Let's not think those. Otherwise, we go for the ore robot first, then the clay robot. We also go for the do nothing, which is right here. So if you have enough clay for the ore robot, or if you have enough ore for the ore. Clay for the ore robot. The ore robot needs clay? Ore robot needs ore. Dang it, another typo. Yeah, ore robot needs ore. Clay robot also needs ore. Yeah, they're dumb robots. They just need that one material. That probably would help or hurt my math, wouldn't it, folks? Let's give this a just show us number. It's not that hard. What are you doing? What do you think you're doing? Yeah, we have do nothing option. We have ore robot, make ore, clay robot, make clay. 1733. Wah. What are you doing? You are putting your robot changes on there, which for us doesn't do anything. Okay. Well, if we have more than 4, we always want to be making. So if I invert this, because they all top off at 4, right? So if more than 4, technically if less than 4, then we do nothing. Which is what we were doing before. Right. $17.33. How dare you? Someone thinks they make a lot of rocks. Who's making all these rocks? And how did you make so many robots? We can inspect that. Great. You have how many? You have 0 geodes. You're boring. You're boring. Yeah, this is where you're literally ramming ore. How do you do that? How do you live with yourself, robot? Yeah, you literally shouldn't be doing this. I mean, physically, you're supposed to be spending it as much as you can. If you have less than 4, but otherwise, you're supposed to be spending it like crazy. Are these not doing their jobs? Inventory ore. Yeah, 62 ore. You make money. Make the money. Yeah, ooh, that would be a tough one, Death Knight Ruin. Yeah, that would be a tough one. I need all this code. I need it. But yeah, thanks for coming on by. I do need it. Now, so what's happening is we're seeing. Well, this is a lie. A two-faced lie. Yeah, like what options do we have by the end of this iteration? Yeah, get in there. Get in there. Yeah, we have the options of show debug. We're either making a robot or making a robot. Where's the robot we made? I can't see the robot. Ore and clay robots, I guess. Right. We should prioritizing though. For sure. Yeah. I got it, Death Knight. I can see how that would work. Definitely be a good one or a tough one for sure. So this does work. We just need to figure out how we're literally cheating the universe and making so many geodes. So edit breakpoint, inventory geode, triple equals what's math? 17. Yep, how do you cheat the universe? Tell me your cheating ways. Okay, let's figure out the cheat. So you make 4 geode machines and you have 17 geodes. You have 1 minute left. 10, 8, 6, 7, 5, 5, 5, 4. 5, 5, 5, 4. So how many did you end up with? 1 ore collecting robot, 4 clay, 2 obsidian, 2 geode. 5 ore, 5 clay, 5 obsidian, 4 geode. I'm just not subtracting at some point. Yeah, so you take the inventory ore, you decrement it by... Yeah, they both require ore. One requires clay. One requires obsidian. Yeah, that part works. And then our options happens, where we do nothing if we don't have enough, or we spend when we do have enough. Well, these aren't if-elses, these are ifs. Interesting. Yeah, the only difference here is which robot we're increasing, right? So both decrement ore, one adds ore robot, one adds clay robot. Easy, easy. Then go through all of these, call the recurs, and find the maximal number. Makes sense. Okay. I guess stepping through this, and then at the beginning, we update all the inventory counts. Yes, we do that. Okay, I guess this is it. We just figure out where we went wrong. Gotta follow it through. This feels optimal. We're just literally somehow cheating the system. There we go. So we have 1 ore, 1 ore, 2 ore, 3 ore, 4 ore, and we make another ore robot. You were supposed to build a clay robot physically as soon as you were able to. Why did you not do this? You had enough for a clay robot, but you didn't. Yep, so let's look at inventory ore. You got 1 clay robot, only needs 2. Okay, so you're gonna go 1 more loop. You're gonna have enough. Yeah, the thing is, this does happen, but it's a push, so we don't see it until recursion lets us see it. Let's avoid this. Alright, so we're gonna want to do what we want to do as soon as we want to do it. I physically want to see all this happen first, so we'll hit this with a dot reverse. There we go. Let's jump through it. Clear them 2 out. There we go. We made a clay robot when possible. Yeah, because we always want to make a clay robot. No, we don't. We want to sometimes make it. I basically went to the same place, just optimizing on one thing and not another. Okay, so we have 6 clay. And we're going to go to 8 clay and 3 ore. 9 clay. 3 clay. 10, 11, 12 clay. 12 clay, okay. How do we make 12 clay? Yeah, what minute are we on? Minute 8. 2 ore, 9 clay. 2 ore. Okay, it's just going a little fast. That's my cheat. I have to track that down. There we go. So I guess I'll need to also get on up here. Yep, minute 2. Okay, I gotta shrink this down to read it. It's too many things. Minute 2, you have 2 ore, so I'll step on through. There we go, I have 2 ore, whoop-de-woo. Yeah, okay, all zeros. Big fan of zeros. You don't even need to do this conditional. You can just add zeros. You'll be fine. It's gonna break the rest of my code. Man, my brain is failing on this one. So we have none, then we're gonna add 1 ore. Lovingly, big fan. Yep, we're not gonna be able to make any of these. We don't have. Technically, yeah, we have enough to do nothing. There we go. Do we have enough to do something? The answer is no. So get on through. There we go. We're gonna add with our 1 ore robot. Gonna go up to 2 ore. Okay, get on through. There we go. And we're on minute 2, so I'm not gonna be able to really do anything. But next time we can make a new robot. Hold up. Okay, you just pushed an option where I create a robot. Now, what minute are we on? We're on minute 2. You create robots at the beginning of minutes, not the end. Oh. Okay, let's move this higher up then. Just do it sooner. Do we want to save this in the cache? I mean, kind of need the cache. Oh. Let's drop the cache. Well, if we're gonna do it, we're gonna want to do it here. So let's go ahead and do it here. Yeah, we'll leave it. If you're out, then return the geode. Otherwise, if you got the ore for it, make the geode. If you got the stuff for it, make the obsidian. Otherwise, are conditional. If you don't have enough, you can't do anything. Or if you have enough for either of these, always make it. Right? I've chosen the 4 because I see all the 4s. Does that not work, though? Hmm. Ah. Huh. Man, at least on the sample case, I should be able to because there are literally just 2, right? Yeah. 4, 2, 3, 4. Yeah. So I should be able to. 4 should be enough in the sample case. But that's. Yeah, I'm not failing at 4. I'm failing at literally cheating somehow. How do I cheat? Uh. Okay, let's drop some of these lines. Maybe we should start cleaning up these comments. Turn best, save best, cache best, all the best for the best. Yeah, come here. Get back over here. I'll go add this to the new object or whatever. Let's see. Yeah, we use the old robots. These don't really mean anything. It used to in a relics day past. Yeah, let's not unnecessarily do this. Because we're already doing a spread down there, so it does not matter. This is your inventory. You start with one ore robot. You have 24 minutes. Initialize you with 24. I'll give you more minutes. No, 24 is the right number. Okay, so we're doing some caching. Maybe we don't do the caching. I don't know why that would give us a higher value, but what if we just did it? Our current blueprint. Nope. Didn't tap that button. Yep, so if you don't have enough, you do nothing. I guess I can do an options check length. Only do this if you've made at least one. Okay, let's give this one a shot. Give her a run. And we are returning the right thing, right? So ID 1 can open 9 geodes. 22. It went up. How the heck did I do that? It went freaking up. Literally the opposite direction. Went from 17 to 20 something. Great, so let's figure this out. If we know the first two don't really get to do anything, we have a clay robot. Because we just spent all of our ore, we will generate clay. We will be happy with it. What minute number is this? This is minute 3. We have 1 clay, 1 ore. Okay, what are we gonna do with all this stuff now? We're gonna put all our lovely breakpoints everywhere we can go. Yep, so we have less than 4 ore, so we're gonna do nothing. We left nothing. So minute 4 is us doing nothing. We have 2-2. 1 clay collecting robot collects 1 clay. Nope. Go back. At some point in minute 3, we have 1-1, which is correct. And then next, we go through here. We update our count for robots. We have, come on, 1-1, so it should go to 2-2. The ore collecting collects 1 ore. I generate the robot, and then I do the collection. Right. So the collection happens after. Yeah, I've swapped these orders. I just gotta put them back, I guess. So generate, then collect, I guess. So, generate, which would be, I guess, modifying this inventory. Inventory dot ore. Drop the requirements. Obsidian, drop the requirements. Robots, increase. Don't do that until there, right? Yeah, and then return these two things. Inventory. Come on. Yeah, because we had to do the generation in the middle there, I think. Same logic. Inventory ore go down. Clay go down. Obsidian go up. Do all this. Eh. Okay, try it again. Try it again. There we go. So we're jumping straight in here, and we don't have any increments anywhere else, which is super fun. Um. Okay, so let's stop this. We gotta put these increments back. So for this one, again, it's gonna be similar. I should be able to use it once though. Hmm. Okay, let's make a not next inventory equals inventory. No, don't do that. Next inventory dot, yeah, just hard code all these increments here. There we go. So now I have both previous and next states. I probably shouldn't have done this, but now we're here. So let's copy this, time travel, undo those changes, and then move on. There we go, and boom. Next inventory right here. Everyone ready to use. Okay, now for the inventory for the geo generation, we're going to use same robot counts, I suppose, with the additional one robot, right? Additional geode robot. Then it's going to be all of the next inventory minus these changes. So it's next inventory. Because next has definitely enough. There we go. We use next inventory, which has the stuff after. Do the same here. Right. And for the other ones, what do we use for you? I guess we also use the next inventory. Do we count this? That's basically the difference between a greater than and a greater than, less than, or equal to sign, or less than equal to sign. But for you, though, don't see why not. If the comparison, don't think so. Then for the recursion, you receive, you push, all that fun stuff. Did we stop cheating our math? Let's find out. Oh Lord, I forgot about that. I'm not seeing any super cheats of geodes yet, but ooh, 7. That's better. Now we have to track down why it's not having enough now. Maybe I need to use next inventory on a lot of these calculations. At this point, I'm just not using inventory, so I don't see. This might be an overcorrection now. Great, an overcorrection. Hey, now it's not enough. We freaking Goldilocks up in here, folks. Hmm. Wait a minute. If that 7's too small, what if I drop this to 0? Let it go for one more. 9. Hey, okay, progress, progress. Do math. So we want our two outputs to be 9 and 24. 9 and 12. You son of... Oh, wait, because it's math, right. Okay, that's actually correct. Oh, jeez. Moment of truth, and then we get to fight part 2. Super fun. A lot of blueprints. Yeah, that's right. Oh, I'm seeing some zeros. I don't know. You shouldn't be able to not generate geodes. Oh, jeez. Well, that's a great sign. Well, we have a number. Yeah. Okay. Back to the board. The drawing board. Hmm. Ah. Hmm. Okay, I think it might need to actually be a brute force thingy or whatever. Let's try and hard code it, or at least try and just get a version working. So whatever this is, it just didn't do enough. So let's just hard code all the things. Ore, clay, obsidian, geode, ore, robots, clay, robots, obsidian, robots, and robots. Finally, our what do we have left? Our minutes left and blueprint index, right? That's all we care about. Yeah, that's all we care about. Okay, and look at that. It's doing lots of things. Let's not do all those things. So we do want BFS, so let best equals negative infinity. Infinity, thank you. Oh, where'd my music go? There it is. Poofed away on me. And we do want to kind of um do a huh. We basically want a priority queue, right? Um I'm trying to remember how I did that in JavaScript last time. Did I or did I just ditch? Hmm. Yeah, maybe we could just use an actual queue or whatever. So const q equals lovely, and then all these numbers. Maybe we don't. Hmm. These aren't actual. No, no, no. I need to receive something else as parameters, not every value, because it's not recursive. It's BFS, so it's going to be a while loop. What do I want here instead? I don't want all this. I do want the time. And this will be called for each blueprint, right? So I guess what I want is or cost. Yeah, but basically how much each one costs, since we are able to hard code it. Class, obsidian, or cost, obsidian, clay, cost, geode, or cost, geode, obsidian, cost. Yep, bunch of hard coded numbers and minutes left. Don't need this part because we encoded it literally into there. Now we're gonna start off with our initial values. No ore, no clay, no obsidian, no geodes, and then our robots. One ore robot, and then none of the other three. And then we're also gonna include minutes left, I suppose. And this is our lovely queue. Well, it needs to be an array of arrays, not this. Now, while queue.length, let's go ahead and create this for our BFSness. Yes, give me a set. Now, queue length, const next equals queue shift. Yep, that's the way we do queues. Yeah, it's const or play. There we go. Beautiful. We pop all that out. I guess we could have done that on the next line. Then we generate our lovely key. Big fan of that. Kind of like the recursive function. Well, we are pulling out the geode, so maybe we'll update best. We'll do it on the front end, not the back. If minutes left is 0, continue, you fail. Otherwise, we generate our cool key. Looking at the input, it's always these 4 resources we're fighting, right? Or, well, it's technically or twice, then or and clay. And we need to figure out which one we're waiting to give the resource to, right? Yeah, we wait to figure out which one we're giving the resource to. Yeah, new heuristic instead of hard coding those things, I guess. We choose the one that's the highest, right? And if we can only ever consume a set rate, we won't need, like, if we'll never, what am I trying to say? We'll never be able to eat more than 4 ore a minute, right? So we'll never need to be able to generate more than 4 ore bots. So I can like hard code the limits for these ones. So we want constantly basically the ore cost, max ore cost, I suppose. Math.max ore cost, obsidian ore cost, and geode ore cost. Maybe? Wait, I'm missing someone. Someone also uses ores. The ore bot uses ores. The clay bot uses ores. Yeah, okay. I did not name these variables well. So this is, what's this? So this is the ore cost, clay ore cost. That's bot and then thing. ore cost, clay ore cost. Does the geode use ores? Yeah, I have it right there. Okay, great. So max ore cost. If no, we're not doing that. Don't do that. If ore, no, we're not doing that. Yeah, get out. Basically, if I have too many, I don't want to ever go over this limit, right? So it'll be a maximum, essentially, or a decrement. So if I've enough or robots greater than max or cost, I won't need anymore. So I'll just, like, top you off, right? So I'll set you to, yeah, you'll never need more than you can generate. Oh, you're a let, okay, or you're a cost, you'll be a let. Great. So same thing for ore robots. I'll also do clay robots since they are essentially identical. I mean, let's just do it to them all, I guess. Right? Because it's because it's a direct dependence. That's why. In the obsidian, we're not going to do it on you because you also depend on clay. Yeah, you're the weird one. Mr. Grinch. Okay, that might set our limits up so we don't go past it. Then I guess we'll regenerate our, because we didn't really do the optimization, did we? There we go. There we go. If scene has, nope. Key equals JSON signify. If key has, do stuff. Or do a new one, right? There we go. Okay, doing some logic here. I guess we'll be adding this to queue. Pushing our, whoa. Whoa. Oh, no, that's right. Yeah, because that's how much we add to the thing. We decrement our time, right? Good job, good job. Now here, if we can get more ore. Yeah, these are our conditionals. Kind of what we had before, but it's basically what we had before. So if ore greater than or costs, we're making one at a time. Don't need to do all that. Add to the queue. Oh, don't forget my actual increments, though. Ah, it's a little painful. But I think, yeah, we can do this. Plus all of these. Oh, nope, get out of there. Plus those robots. Yeah, so we can hardcode that. Copilot should learn. Otherwise, we do the same thing for the clay one. Okay, don't. No, don't. I didn't ask for that. We're making a clay robot right now. There we go. Let me push. Nope. Nope, we're not pushing on that one. We're pushing this one, which is minus clay or cost plus clay robots. Hold on, that doesn't seem right. Yeah, my ore is going down, not my clay. Darn it. Clay or cost. Yeah, okay, that's right. Now the other robot, there are only 4 robots, right? Is the obsidian one. So ore greater than obsidian ore cost and clay greater than obsidian clay cost. Good, good. Okay, I'm gonna let Copilot take the wheel. Decrease ore, decrease clay. Good. Okay, last one. If ore greater than geode ore and obsidian greater than geode obsidian, drop the ore, drop the obsidian, Okay, again, so it feels again like we've done the same thing, but we have our lovely queue, putting lots of things in the queue. As keys, having a freaky. It feels like these maximums are not enough. Let's see if we can get by without them, to be honest. I'm hoping this is efficient enough in Python, in JavaScript land, as it is in Python land. We'll see pretty quickly. We're not calling recur, we're calling BFS. I guess we're initializing all these zeros, so 4 zeros. Actually, these are all blueprint values, so never mind. Freaking Copilot. Just use the parameter names, be cool. No, okay, great. So it's or cost, so blueprint, no, blueprint dot, okay, it's a thing, or bot, play, bot, we'd make the other two. Thank you, thank you. So it's blueprint. Now, which are the arguments again? Or cost, or bot requirements, or play or cost. So play bot requirements, or obsidian requirements, or geode obsidian. Yeah, hard coding all the things. Did we get enough? Looks like we didn't. Yeah, geode. Yeah, that was obsidian clay cost. Okay, so we're looking at obsidian ore cost, lovely obsidian clay, obsidian bot requirements, clay, then geode ore, and then geode obsidian. And then minutes left, and great. Okay, let's see if that works. BSFS says return a number. Should return this number. Why are you angry? Expected. Oh, no, great. Too many arguments. Be happy. Be happy, I say. We love an infinite loop. And we do need more of this. So we have 0, 0, 0, 0, 1 ore bot, 0 the others. And it's left right there. Big fan, big fan, big fan. Uh, hmm. I mean, we infinite looped somewhere. Ah. Hmm. My brain is not enjoying this. Hmm. Okay, I know the shift isn't free. Maybe we'll swap it to a pot. Treat it as a stack. Maybe that'll make it go fast. Oh, Okay, we got the 1. Okay, it's going to be a painful 23 is not equal to 33. Dang it. 1, 7. So you were able to generate 7 for some reason. What did I? Okay, these 4. Let's drop these. So we're just trying to follow the rules at this point. No optimizations to include. Although I guess there were optimizations because we mutated and modified the state, which hit the cache. Okay, yeah, there were optimizations. We gotta make more of them then. Yep, max or cost. We have to figure out more optimizations. We should be able to make it for all of them. So this is where the math comes in. Okay, yeah, I can see it's slowly brute forcing its way through. We will at least get part 1 out of this. I mean, it's taking a long time just for these blueprints. It should be equally long for all these blueprints, though, I imagine. So my check is basically checking it, or what we need to do, like take obsidian, for example. If we have enough obsidian that you can generate another geode bot. No, we need to max out. So the same way I maxed out these, we need to max out the other parameters, but it'll be based on the requirements of the other bots. So if, or we'll start with or, since that's sequential, it's greater than or equal to, and this is where the math comes in. So we have time left. What did I call it? Where is it? Minutes left times max or cost. You're still using that. So this is for the ore robot. Basically, do we have too much ore we need to get rid of? If we're generating more than we can consume, we can flatten it off again to the top. Minus ore robots. Giving me some good ideas here, Copilot. Oh. We're already using it once. Let's see what this does. Yeah, it makes sense. Whatever we're using, it's going to be reassigned to the thing. Now, if we just do this for the other 2 resources, maybe we could do clay. Yeah, because clay is also dependent on the ore. But it's not on the ore bot, it's the clay bot. And we're not updating ore anymore. We should be updating clay. And same thing for obsidian. We don't do geodes because we actually care about geodes. So, got clay robots, but obsidian robots. Did you finish running? Son of a... Oh, great. Too many things in our set. Well, we're about to fix that, aren't we? By basically math-maxing manually all of our things. Yeah, and again, same way we did only the 3. We do only the 3 down here. Son of a... Oh, I didn't need that. Thanks, VS Code. Do me a scroll. 5. This flattens out. We need the next minute, right? Oh, and we're also missing this. Oh, geez, everything went off the rail for that last one. Oh, there it is. Autocomplete. Love you. Big fan. So, what do we want? Less? Yeah, because it's the next minute we care about, not the current minute. Dagnabbit. Well, it's still the same. Ah. Treat this back as a thing again. Shouldn't make any difference. Oh, it doesn't. This is how we use mathematics or cost, clay or cost. These are all the costs. Yeah, so the cost of ore for the ore machine, the cost of ore for the clay machine, the cost of ore for the geode, for the obsidian machine, and the cost of ore for the geode, because you are our limiting freaking resource. If we have more than we need, then flatten it. If we have more than we need, flatten it. More than we need, flatten it. If we have more than we would need in a sec, in minus our minute. Yeah, minutes times the max minus that times that. Then update ore, clay, and obsidian. Okay, these all look right. Let's make it pretty though. Yeah, these all look right again. Dang it. Did I not put these things correctly back? No, these are all updates. Obsidian, clay, and ore. Scene has it, otherwise scene add it, or do all this. Now this works. Did this work? Yeah, we're all going minutes minus one. That part's right. So let's reread this again. If we have more ore than we can, we're going to go ahead and try and make more. So decrement there. Add ore robot, add clay robot, add geode robot, add... Did you just add 2 geode robots? Son of... Wait a minute. Wait, it's on the right side, yeah. Add obsidian robot, add geode robot. Okay, that is correct now. So your cost spending ore and spending clay. Max ore cost obsidian robots. Hold on. Not max ore cost. Because you're not costing the ore, you're costing the other things for this robot. So the ore one, yeah. The clay one. What's the second? Obsidian clay cost. There we go. Yeah. So then for the next one, it's gonna be geode ore cost or geode obsidian cost. That seems right. So did I change anything down there? No, I think I just looked at things. Well, now this is taking forever, so I guess I broke the cache. Maybe we did need to use the cost of there. Math. Not even once. Yeah, so this is for the first ore robot, clay robot, obsidian robot. Right. Math. Yeah, this is same. Yep, same math. I'm doing shift. Let's not reference that. Oh, 23 is now what's wrong with you? 9 and 7. So we're back to the second one, not running enough. We're not generating. I did believe I got 16 finished. What was 16? Yeah, I actually was able to get 16 finished lamb sauce. It wasn't so like it wasn't like I was on the right path before the monitor died. As you can see, it was adding the elephant to the sequencing, and basically this bit here was the new part. So like if we're doing an elephant check, then also try and open and close the valve. And like this is the part I was missing from the whole algorithm. I wasn't backtracking to close the valves I had tried to open. But aside from that and adding the elephant additionally as the pathfinder, that was all I was missing. Yeah, I was able to get that one solved. Okay. Wait a minute. How much does the geode cost? Yeah, geode cost or an obsidian, right? Huh. Mm-hmm. Okay, that seems right. Just being like, is the universe still spinning? It is. Okay, glad I figured that part out. Okay, so the second one not running, it's gotta be a problem with this one, with this bit down here. So if we have enough ore to buy a clay or an ore bot, then we decrement our ore, increase our this. All of those stay the same. We add one to ore robot, one to clay robot, one to obsidian, one to geode. Great, so the back end is perfect. If we have enough ore for a clay robot, then we spin the ore and move on for a day. If we have enough ore for an obsidian robot and enough clay for an obsidian robot, decrement our ore by that, our clay by that. Otherwise, we have enough ore for this. We have enough obsidian. Then we do that there. Yeah, these seem perfectly fine. Expensive as heck, but perfectly fine. Yeah, this optimization should not be slowing us down. If anything, speeds us up. So this is our problem. This is the only thing mutating stuff around here. Yeah, so if we have enough ore robots, or clay robots, or geode, again, we're doing the same comparison to the things we shouldn't be. If we have more clay robots than clay needed, and if we have more obsidian robots than obsidian needed. That's what we want, I think. Hey, of course, lamb sauce. Yep, it's all on the GitHub. Which is updated to yesterday's code. Oh, great, it's running. I think this is good. 1140. I ran on an 11 number already. Phew, okay. How badly have I done this year? Nope, that's not how you click the pages. Ah, 2 hours into the first one. Yeah, this ain't gonna be. We're starting to teeter off. Dang, we're not teetering off that badly. Okay, I guess it's not that bad. While you were choosing your blueprint, 32 minutes. Okay. Elephants ate the freaking elephants! The largest number can open is 56. Okay, so go for longer. You no longer have enough blueprints to worry about quality levels. For the first 3 blueprints, determine the largest you can open, multiply. Okay, so we increased the minutes, I guess, and then we're doing something? The heck are we doing? Doom and... What are we doing? For each of the first 3 blueprints... Is this a sliding window? Sliding window, I don't know. For each of the first 3 blueprints. Oh, do I just only care about the first 3 blueprints? Is my brain simply not understanding of that? Let's clean some of these up a little while we're here. Recursion function. It was nice meeting you. You broke my brain. And then I had to bring out math to solve it. Very painful. Not a fan. Yeah, let's see how part 2 is treating us. So I guess for part 2, where'd the minutes thing go? I guess we'll grab my input first. There we go. Big input. How you doing? We love you. Boop. Paste. Well, I guess we don't customize here, do we? What's 62? Wait a minute. Using it. Like, give me example of what I'm supposed to spit out for my example. 32 minutes, the largest one can open is 56. 2 can open is 62. Yeah, you're not giving me a number. You're not giving me a number. All I know is 1 and 2. I don't know 3 or whatever the heck. 1 equals 2 equals 62. And it's 32 minutes now. Cool. So I guess we can hard code that bit. Where did I call that? Way down here. Yeah, easiest change in the world. Now with the fun part. For each of the first 3 blueprints. My brain hates that word. For each of the first 3. Each of the first 3. First 3. Okay, so I guess it's literally first 3. Dot slice 0, 3. That's 0, 1, 2, 3, 4. I remember how slice works. Don't look at me. There we go. Slice 0, 3. That does the trick, and since that's not an array, you're all angry. Okay, yeah, and then we do the same thing? Yeah, we're only summing these 3. Does nothing change? Oh, wait a minute. Blueprint, the number of geodes you can open. Oh, look what you did. Look what you did. You're not doing the index score thingy anymore. Okay, so I already know this takes half an eternity, so let's turn off our little iffy. That's why we love iffies. 2 deletes and it's off. TS. Is there something else I was supposed to do aside from going on? 32 minutes. 8 most of my blueprint. That's 32 minutes. So from the example, I should see 56 and 62. Oh, it's also a lot more minutes, so might be more. Oh no, my cache is dying. How long did this other one take? I started seeing a lot of output quite quickly. Maybe that's why the trimming is down to 3 blueprints, cause lordy oh lordy, gonna take a minute. Ah, awesome. Interesting. Uh-oh. Okay, so... Well, we're not even making it through one blueprint. We gotta do this. This is gonna be a sixth of our input. Such a large queue, I imagine. And this isn't enough. I can't optimize the last rowboat though, because that's literally we need to get to there. You're doing anything. Going to remove console logs, is that why? Nope, console logs still here. Solve 2 is what we're running. Phew, man. Man. This is where I know Python would run this quicker. If I had PyPy, I'd also run it super quicker. I have PyPy installed. It's been a while. I didn't have PyPy installed. Am I still using the pop on this thing? Okay, great. Just want to make sure that was cool. Oh, great. We can't install stuff. Value out of range. Son of a. Okay, it's too big. What do you know? And we didn't even get through one of the blueprints. That was, cache not big enough. Yikes. Oh, please, yes, please install. We actually need to drop down to Python. So how do we trim down other branches, right? We need to not go down other branches. Yeah, again, this works, just not good enough. Kind of like the very first one. It worked, but it wasn't good enough. Maybe we make some always assumptions, right? So we are always buying a geode. Yeah, so we do some of these. Right? And then geode push continue, right? Because if you can, you will. Otherwise, we'll also drop one here. And these are the two. Obsidian bot. What are you doing here? Okay, you're supposed to go up here. These quick and early ones. Maybe this will help a little bit. Oh, we're not reinstalling PyPy. And I'm in the wrong folder. I guess I really should be doing this to part 1 to make sure I'm not breaking the algorithm. But that's what console logs are for. We're doing this to part 1. Let's Ooh, 051. Dagnabbit. 62. Wait a minute. Oh, that one is correct. 32 minutes, the largest. It can open as 56. And then our output's 54. I mean, it's not gonna multiply these numbers together, right? So 35 times 11 times 8. Who's gonna stop me? 3080 Ti. Wow. Oh! Oh. Imagine, just imagine if I was like, oh, obviously the first input's wrong. We gotta figure it out. This is what happened last time, right, folks? Just because it doesn't work on the example doesn't mean it doesn't work, as counterintuitive as that is. Yeah, Death Knight. This code still doesn't work on the example, but we won't tell no one. Phew. That was a tough one, folks. Yeah, basically, not too bad. I am curious though. Okay, before let's not get too curious. Let's make our commit. Yeah, lamb sauce. We did it. Optimize. Oh, I guess that's still a commit in the chamber. Is it still in here? Didn't we do this last night? I guess I just forgot to click commit. Good job, past me. May 19. Wow. And there we go. Yeah, I'm feeling energetic on that one. Let's hit up the optimize on part one. Let's turn the iffy back on while we're here. Let her rip. Oh, we also got those extra console logs. Let's clean those up. Yeah, we don't want to see all of them anymore. Where'd they go? There we go. Now what did I do? But yeah, I'm definitely seeing lots of refactoring, or basically just copying and pasting at this point, because our BFS is identical. 1147. Don't. Oops. Go back. Refresh. Come on, you. There we go. So the first one was 1147, and the second one is 3080. Still taking a moment to run here. Oh, that's because on the real input, right? Yeah. Gonna start needing progress bars. 54. Oh. Oh, multiply together. Whoops. Man, I'm glad I manually did that. I lucked out there. Is it add? Multiply these numbers together. Right, yeah. Make sure I initialize sum to 1. So that's how multiplication works. Do it again. I am glad. I am so glad I decided to manually shove those numbers in. Yeah, I guess while we're waiting here, let's begin our optimizations. So let's parse blueprints. Oh yeah, all this is so hard coded. And first is just gonna be getting this not wet. Then it's gonna be getting this thing actually dynamic. Make a nice little BFS. Basically this entire lovely function. Boop. Boop. Now you didn't need any globals, did you? You weren't accessing blueprints? No, you're cool. Very cool. And for all of these, you call cool BFS, you do math. 3080. There we go. Good math. Yeah, what was? Since you're here now. Come on. This is where console. So you literally did not show me my third output, so I had to guess. Yeah, while you do that, go ahead and give her a run. Yeah, now again, this data, very hard-coded. But that's working on that front. Polish this one up. Product, there we go. Again, BFS is literally identical. Glad we got that part. I don't even think we need the index anymore. We didn't need the index for that one. 3162, what do you know? Big math. Okay, good there. Well, we're going to refactor our blueprint parsing a little bit, make this life a little easier. As much as we love this, we're going to check our reduce on here. Another object, we're going to destructure out. I mean, because we could destructure out the index, right? So this is going to be,
Hold on. Robots. Awesome. I went too far. You're the one that needs reducing. You're going to restructure based on robot and requirements. Then you're going to return a new object, obj, with robot requirements. Initialize lovely empty object. Thing's freaking out. Yeah, it's an array. Indexes, that should do trick. Okay, where have I syntaxed this up at? Ah, there we go. There. Lovely. I have to take a quick look at my blueprints. Yeah, it does not exist on objects, so now I can directly access my robot. Does not exist on type objects. Okay, I'll just TypeScript up again. Alright, here's how we did it last time. Except it's a little different. The value is a number. It's a requirements. Requirements is another object, so it's objects all the way down. Again, we'll dynamicize this, but we ain't there yet. Great, so GeodeBot is a record. Oh, yeah, we lost the requirements, didn't we? Oh, well, we still got some. There we go. Update the next one. Again, a very static approach, but we'll figure this out in a momento. Still two more. Yeah, there we go. Now, with my hard codings in BFS, I don't see this being super optimizable, unfortunately. It looks like you didn't need entries, so toodaloo to you. You just need values, which is you're an array, so you're already this. Like so. Beautiful. Okay, let's make sure this still works. And start trying to de-hard code all of this. I mean, this works. Well, does it still work though? Okay, it does appear to work. Yeah. Dang, it's very hard coded. Maybe I put these back into objects now that I kind of have them. Or costs. No, here's the thing, because I don't need them in this format to serialize, but as we saw, I kind of ran out of space. Started to at least. And it was just on a scene, not even a real map actually storing the values. Okay, I guess I can rename this queue to a stack at the least to be more accurate. Let's move this scene up. Keep the related things all together. Clay ore cost, obsidian ore cost, obsidian clay cost. Yeah, okay, I mean, I could just start pushing objects and reconstructing this to make these variable names better. So I just passed the 4 bots, right? Yeah, so Orebot, Claybot, Obsidian, and Geode. Now we'll do this on the one that runs fast. Oh, this is the one that runs fast. Oops. Orebot, Claybot, Obsidian bot, and Geode bot. Then I'll have to, inside of this, start pulling all these from out. Let's make an interface real quick. Interface bot. Bot requirements. This you can make all 4. Thank you. Although, never mind. Heck, this literally could have been a record. Thank you. Now we can reuse that. Bam, bam. Well, I went a little too far. Nope. I thought it was wrong, but it was right. There you go. So now you don't take these. You take all the bots. Or bot. Play bot. Obsidian bot. Geode bot. And here we go. So ore cost is ore bot ore. Clay ore cost is clay bot. Ore, obsidian ore, so yeah, you can see the pattern. And geode ore. I think this is gonna end up readable. Uh-oh. Okay, there we go. Made a typo. There we go. What else? Basically, I'm tracking down all these variables. Well, the Q doesn't actually change, does it? Yeah, it's just our numbers. Or bot. Argument. Not assignable to type number. Did I do something? 1, 2, 3, 4. Ah, too many. There we go. Or clay obsidian geode. Ah, double obsidians. There we go. For these, we don't need to. Yeah, we can pass it straight like so. I guess they're all possible falsies. The blueprint always contains all, so, oh, never mind. You got it. There we go, we can inline that. Lovely, which means, of course, we can return blueprints, or this, we can return this, dot entries, and turn that into an array, so we can call a dot reduce, and then we have our sum, blueprint, index, logic of this right here, initialized to 0, of course, sum plus. Instead of using B, I'll use I. All of this, get rid of, and return like so. Now, why is this not liking it? Blueprints. Ah, I did entries. Don't want entries, we just want the values. Because we only use entries to get index, array, or reduce will give us our index. Lovely. Yeah, I think that's good. Let's try to think of better ways to do this. Oh yeah, this one's on fire. Let's go ahead and update this. Blueprint ore. Clay. And yeah, come on. Kind of sucks I wasn't able to actually come up with the algorithm for it. Like I'm cheating by hard coding the limits for these 4, but a solve's a solve in my book. I will be curious to see if I can even understand the Reddit solutions. Oh, thank you, Copilot. Yep, that's right. That's exactly what we wanted to do. Although we only wanted the first 3, so let's slice 0, 3. Because I guess even Advent of Code was like, we're not going to make you spend this long. We're not that crazy. You know, these here, we're doing continues, but we can do it better. So this, else, gonna try these two. Makes the flow logic a bit easier to follow. There you go. So if you can do the one, or you can do the other, or you can try either of these to your heart's content. Now this logic. Let's put these up beside each other. Can we? Yeah, we can. Because right now it's like doing one thing for three things. I'd like them to all be beside each other. There you go. So we're updating the number of robots and updating the number of clay to reduce how many we go in the cache. Yep, so more than need or more than consume. Let's inline this continue while we're here. Or we can just not push these to begin with. Well, we do want to do the maximization, so we either do it down here 4 times, or we do it up here 1 time. We're doing it up here 1 time. Now I'm putting an array of numbers, which works. What's the bit shifting trick? I'm trying to think. Store. Oh, that's for booleans, right? Yeah, I want to bit shift a bunch of different numbers. What are their maximal values? Because that will tell me how many bits they'll consume, right? Your maximal value is like 32. Maybe I can ask Copilot. Make it generate a bit key. Is that how it works? I mean, let's turn it off, see if this runs. Well, let's give us a time on this. I feel like that's just raising to the power. I don't know if that works. And I'm down to try, though. Always down to try. That's a boring set. Don't even know what's inside you. Yeah, Death Knight Ruin. That's part of the learning process, you know. It's like remembering what your data is. So it definitely helps with that. Because the reason I was able to like chain all that stuff was because I was like, okay, I'm already assigning this to variables and doing with it, do the exact same thing, but instead of the variable, it's the returned value. So instead of saying const blueprints equals parse blueprints and return blueprints, this you kind of like it's the process of I don't know why this is broken. It's the process of like realizing that this was the variable the entire time, and that's a lot of like knowing methods and remembering return types. So like in this one it was pretty easy because it's literally a variable replacement, but in the reduce was kind of just state reduction. But yeah, I don't have any good examples in here. But yeah, maps and sets, again, they're not the nichest data structures, but they're the very few ones we have in Vanilla.js. So definitely, I'd say, good to get a handle on. Thankfully, their interfaces are practically identical. So if you learn, like, maps, you will have basically learned sets, vice versa, with, like, a 5% difference. Okay, yeah, for sure, Death Knight. Then yeah, like I said, I mean, I say if you learn maps, you'll learn more than sets. So, because a set like is basically half a map, you know, because you got your keys and you got your values. Map is both. A set is just the keys. So if you learn your map, you're gonna learn much more. And then when you go and learn your sets, you'll basically see, oh, it's all the same. And there are even a few set methods that are literally only existing to be polymorphism with maps, like set.keys and .values. Obviously, there are no values, so the values end up being the keys anyway. So yeah, they're very good to learn together. I say, like, as far as data structures built in JavaScript, that's all you need to know. You don't need to necessarily go learn what a weak map is or a weak set is, because no one uses those. Look at that. It's faster. So we'll do, look at that. This is the way to do it. I am curious, though, what is this number? Because as much as I love just stealing code from Copilot, I would like to understand what the heck this does so I can do it on my own. Big number. Okay, I don't really understand how that helps. 24,000,1,00,000. Does this not run the risk of collision? See, that's what my brain is saying. It's like I can do a bunch of bit shifts, but like, what if this number in the 8 position becomes 2 and then 4? It would be indistinguishable from 24. My brain doesn't like this. Not gonna. I mean, it does technically run and it does output the correct solution, but I'm not gonna trust it, so we're not doing that. Much as I want to do the cool number key, I'm not confident enough. So JSON stringify is our hero. Well, at that point, I probably don't need to do a fill JSON stringify. I can do a join, right? So what is that? State. There we go. I think that'll be cool. Yeah, let's give it another time because I know JSON is it's basically the eval of expenses. But the other way, did I need this state for anything but the key? No, I didn't. Would you look at that? That's not really going to increase speed, but do I need the key for anything but right here? I do need the key like twice, so. And then all of this hard-coded math. I guess these 3 can be flipped into cool things. Most or needed. Oh, 38 seconds. Great, we love that. Const most or needed. Right? Okay, let me make sure I get this math right in my head. So if we have more than the most we will ever need, most or needed. Yeah, that's right. Well, actually, or equals math.max. Or, oh, wait a minute. If or is greater than, then we're doing a min. The least of or. Is it confusing yet, folks? Is your brain as scrambled as mine? Ooh, this could be a total one. That's or robots. Yeah, no clamping there. I was about to be like, we clamp. We no clamp. Clay equals. I mean, let's see if Copilot could do this. There we go. Minutes, obsidian, clay robots. Great. Now, it's going to be really easy to see if this works or not. Yeah, we're just going to trust. It does make it a little bit cleaner, though. A lot less repetition of that terrible math. You know, this can be swapped into a max also. Let's just see if it works as we do that. So, if or robots greater than max or robots. Oh, okay, my brain. Wow, that one threw me. Can you just figure it out for me, Copilot? No, that's not right. Okay, so if or robots is greater than max, so it's math.min. See if that still works. Okay, it still works. Then we do the same thing. In theory, and then Okay, that's a good theory. Still, I mean, we're running. I know we're running technically faster because these function calls are not free, but I think it's more readable. Yeah, Clay Robots is the least of. Yeah, that's more readable in my brain. Let's add some spacing. We love spacing. Okay, we don't need that much spacing. We need that much spacing. Yeah, these are all of our state checks. Now, I guess if I really wanted to, I could have done this recursively, but I think recursive is even more expensive, hence this working its way out. Geode robots. I guess we could shove those. So, if I really hated people being able to read my code, I would do this, which is completely valid because the assignment operation evaluates to what it was assigned to. So, if I just like hated people, I would do that, but I'm not going to do that. Okay, last look to see if I can think of any way to make this dynamic and not all hard coded. Dynamic to mean something, not dynamic just variabilize stuff. Nah, I don't know the algorithm for it, unfortunately. Okay, let's clean this bit up for the last chunk here. All these inline returns. Toodaloo. I hope I got it. Yeah, looks like I got it. Auto format, yeah. Congratulations, you're an arrow function, Harry. You're a readable arrow function, Harry. Constant robot requirements. Yeah, because we're gonna need that. We didn't need, well, we did kind of need this. Yeah, lots of splits, maps, regexes, all could be done better, but it works. Yeah, clean to me. Exactly, Darth Knight. We don't want to go too crazy. It's just verbose. I don't think I need help this at all. Each map split. Oh, double map. Can always get rid of a double map, folks. There you go. Then we're doing a double rec split here. Let's call these something else. For a line, split the word each, slice. Then what do we have here? I guess we'll call these text since I can't think of anything better. Robot requirements. I'm doing a map and a reduce, which can be stringled into a single reduce. So we have obj, text, congratulations. Where is it? Oh, this is the one I'm dropping. It's a record to the bot. So drop that there. Close it up. Our lovely new object. Congratulations. Then we'll put it in the object. Robot equals new object. Return the object. Expression string cannot. Don't worry, you're not a string. You're a real boy. As that's not how TypeScript likes it. As oh, come on, I know how the words go. As or play is not assignable to blah blah blah. Yeah, because we're not doing that assignment anymore. We are. Whew, okay, talk about a rewrite. Everything else is angry because I messed it up. But this should be correct. Oh, I'm missing some. Where? Here? There we go. Missing a curl or a parenthesis. There we go. So for each line, hold up. Returns a record of these to these. That reduce doesn't feel like it's in the right spot. It feels like it's inside the map. This doesn't run, doesn't it? Okay, I am the one who is wrong. Okay, again, we're doing another map reduce. Can we reduce to a single reduce? Another objecto. As bot requirements. Say goodbye. Wait, what was it? Resource is the key. obj resource equals parse int count. Turn obj. Gotta probably type the key again. That's right. Let's give it make up another type. Type resource equals. Thank you. Boop. Oh wow, look at that. I could have. Let's go further beyond. There we go. TypeScript is now happy. Hit me with an auto format. Good enough. Robot, we need that. Requirements, we need that. Split reduce. Big fan. Parse int. Yeah, just be safe and all. Okay, let's call this one, requirements object, big fan. This one is bots. Okay, I'm loving that. Well, we're not importing blue from colors. We ain't coloring anything yet. No visualization for this one. Dude, how would I even visualize this? I mean, it'd basically be like generating some cute factorial thing where it would be like a bunch of little bots or a thing with a multiplier. I don't think it would actually be educational or useful in the slightest. So again, one of the ones where the priority queue for visualizing this is very low. Oh, we didn't need that index. Okay, final run. Let's see if this thing still works. Probably we could look at the output, maybe. No, we're not looking at no output. We don't need to see an output. I mean, it's getting slower, which I know it's gonna do that, but it's more readable, you know? Those few seconds are not worth someone being like, what in the heck does this do? You know, and if you did care about time, you wouldn't be using, I mean, it's not TypeScript fault. You'd be making a better algorithm. Or Clay, yeah, still a bit of hard coding. Now here's the thing, some of these aren't exactly type safe. So this thing, for example, aren't always there. It's like when I say .clay, I know it's there, but it could not be. Yeah, I kind of fake the type safety, which is good enough in my brain. Okay, this can be made a lot easier. Let's update this. Or const new minutes equals minutes left -1. And all of these, like they're all this plus this. So it's like const new or new, what's the thing? New clay. Bingo, bango, bango. Okay, y'all. Whoa. Whoa, Copilot, I appreciate you. I was just gonna do math. How did you even know which one to use? Oh, you hard code a thing. Yeah, we're not doing that. Whoops. For robots, clay plus clay robots. Yeah, there we go. Manually adding it up.
obsidian robots, and then geode plus geode robots. Now, instead of doing all the math down here and having a 213 long line, we can do some of it up there. So let's see. All four of these go straight into here. Stack, push. There we go. Stack, push. Nothing changes. And then we can jump with this. New minutes. Big fan, big fan. Here comes the fun one. So these three, since we don't change any of them. Oh, never mind. There we go. So it's new or minus how much it costs. There we go. And then it's new obsidian minus how much it costs. And new geo. So I guess I can do some click and replaces here. There we go. And we're do another click and replace for new clay. There we go. New obsidian. Right, there's one. New. These ones gotta be manually because the subtracto math. Then, yeah, all these gotta be manually. New or. I think I can. Yeah, I can delete both of them. And add them right here. Okay, I'm loving this. And the robots kinda just do their thing. Ore robots, clay robots, geode, obsidian. And it's a little weird order, but it's the order in which we care about them, so it's accurate. We can flip these around for the nice line. So instead of being like this way and then this way, we like a nice line. Easy on the eyes. Okay, so this is good. Make sure we didn't break it. One more optimization. So we have a lot of ore bot, then we have robot, or wreck. Or cost. Or cost. No, or bot. Wreck for requirements. Claybot wreck. Just to distinguish from the or robots and stuff. Yeah, 3 extra letters. Ain't gonna end the world. There we go, because now we have these, which are counts for how many robots for each of those exist. Okay, and plus, like, you can also, with the syntax highlighting, tell, oh, these are all staying the same. What's changing? All the fun stuff, and it still runs good. And with that, yeah, going through the commit. 2022 J TypeScript solution. And there we go, folks. That was a tough one. A lot of math, and I tried to do the dynamic, but sometimes, like Leon says, you could lose, what is it? The trees for the forest or the forest for the trees. We're like the alphabet one, like trying to be super optimized over an array of 26 instead of being like, these are your requirements. You're not planning to take over the world. You're not planning for 15 million outcomes. Your outcomes are very hard coded, and they are very hard coded here. Ores cost ores, clays cost ores, obsidian cost ores and clays, and geode cost ores and obsidian. So don't get lost trying to solve the super problem. Solve the problem you're given. Let's go see now on the opposite coin of that. Let's see how the crazy people solved basically automation of all the cool stuff. 3D printed obsidian chunk. Oh yeah, all the visualization. So 17 is going to be a great day to visualize. Wow, it's going to look great. Python. Okay, Python. Well, look, someone actually did use PyPy. Didn't use any heuristics. How did they not use any? Well, they used PyPy. Hey, nice. Oh my goodness. Okay, I love you people, but your variable names at some points. Rust is a must. But it's not. But if it was, it'd look like, oof. Okay, again, well, it's good hard coding. Okay, so no one, maybe I was the crazy one to be like, let's solve world peace. Okay, I bet I can follow this. Ooh, a more optimized version. Flex on me. A state can be pruned if building a new would cause generation. Oh, I did that. I did that. What the heck? Building a new robot that could have been built last minute, but no robots. What the heck that means? Building a non-mode geode. I guess I kind of got there. Oof. Now's a great idea. Let's not read any more Rust code. Ooh, C++. Is there any? There is one JavaScript fellow. Oh, you did this in like 30 lines. The heck? Okay, so what the heck? Okay, that's your sample input. You hard coded all your data. Okay, so you shortened it. I understand what that is. At least you left a legend for us. Where's your obsidian count? You don't have obsidian cost here. Wow. Okay, yeah, you really. So this is what I did, but they've hard coded it on the number, which is cool. Okay, then cache. We love cache. String plus. Okay, that's a weird way to stringify it, but cool. Callback. It's a bunch of booleans. Oh, you're putting all your booleans in here for caching. A different breed of people. Maybe yeah, this is why I'm not hitting the leaderboard. You know, I'm not using these two variable names everywhere I can. But this I can recognize. This is our recursion. So they did go full recursion. Um Min Obsidian Rock. Yeah, okay. I can't follow this. They practically obfuscated it from my brain. So yeah, I guess recursion was an option. Simple brute force DLF memorization. Random optimizations. There we go. There we go. That costs 4 in the first 3. Capped ore miners at 3. Oh. Interesting. But yeah, there. Oof. Tough one, folks. But we got it, and it looks like no one else is really doing anything fancy either. So that was the appropriate way to do this. So with that, that ends the stream. Let's find someone to raid. Any suggestions? Feel free to drop them in the chat. We will pick this up tomorrow. Wow, Sunday or like a Sunday night. Not a lot of people on. That's cool. We can find someone. Oh, okay. I see one advent of Coder and Python. Oh, there's yours truly. Do 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 do. Okay, what language is that? Rust. We like Rust. Do 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 do. Wait, is this the bottom of the list? Okay, Twitch is broken. I've reached the bottom of the software and game dev category. Probably it says Firefox is broken or something. Oh, there's someone. Okay, yeah. So we got. Let me go watch some ads real quick before I send y'all off. Do 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 do. Ah. Again, if there are no suggestions, it'll only be another minute as my internet's like, how dare you? Oof. Yeah, I'm literally just waiting for it to load. Let's close some tabs. Some tippy tabs. Eh, I got something open somewhere. Oh, close that one, close that one. There we go. Hey, yeah, we got someone solving actually day 19 also. What language is that? Ooh, that's Python, not... Okay, it's not Python, but it's pretty close, folks. Go ahead and show them some love if you'd like. Eh. And yeah, I will catch you next time. Never seen them before, but they only got 3 people, so figured they could use some love. Yeah, lamb sauce. And like I said, I got that oh, let me make sure actually. Thanks for reminding me. Your presence reminded me. Repo is up to date, folks, so the code is there if you want to tear your brain apart trying to understand it. But yeah, see you all tomorrow. Have a good one. Toodaloo.